Hey guys, welcome to our next podcast. This one is all about machines. The definition of a machine is a device that makes doing work easier. So remember our definition of work for physics. Something has to be moving, and anything that helps you move things, by definition, can be a machine. There are 3 ways that machines can help us. The first way is by increasing the force applied to an object. When you think about this, imagine a wedge, like a knife cutting into an apple. You apply a force to the handle of the knife, and it directs that force and pinpoints it down to the sharp point of the knife and helps it cut through the apple. The next way is by changing the direction of the applied force. If you want to think about this like you're opening a paint can with a screwdriver, and you push down and the lid of the paint can goes up. The third way is by increasing the distance over which a force can be applied. Imagine you're having to push your grandmother up a wheelchair ramp. Would you rather push her up a really short, steep one, or a long one that isn't so steep? By increasing the distance over which you have to push her, you actually make it easier for yourself. A compound machine is any combination of 2 or more simple machines. So anything that isn't just a basic simple machine is considered a compound machine. This could be everything from a pencil sharpener in your classroom to the car. Mechanical advantage. This is the number of times a machine multiplies the effort force applied to it. This is basically a number that tells you how useful a machine is and how much it is actually helping you do work. If a machine only has a mechanical advantage of 1, does it help you do any work? Think about this. If the effort you put in is 1 and the mechanical advantage, or what you get out of it, is 1, then no, the effort put in equals the resistance you feel, and it's not really a machine because it really isn't helping you do any work. It actually has to be helping you. It has to have a mechanical advantage over 1 to be considered a machine. So anything over 1 would be a machine. Efficiency. This is a measure of how much work put into a machine is actually changed into the work done by a machine. Basically how efficient the machine runs. Efficiency is never 100%. Any idea why? The main reason that machines aren't 100% efficient is because of friction. Friction always causes machines to be less than 100% efficient. But where does this energy go? Is it lost? If you remember, we've talked about the law of conservation of energy. Energy is never lost or destroyed or created. It is only transferred. And so in a machine, the energy is transferred from mechanical energy into thermal energy or heat due to friction. Oil and other lubricants are used to reduce friction in machines. Think about this in your car. You have to have oil in your car so the parts don't rub together and get too hot and cause your engine to fail. Air resistance is friction due to air. Think about this. As a pendulum swings, remember we watched the clip of the Newton's cradle, and eventually the balls of the Newton's cradle came to a stop. They came to a stop because of air resistance. That's friction in the air as they swing back and forth eventually pulls them down and causes them where they stop completely. And lastly, the formula for mechanical advantage is mechanical advantage equals the resistance force. That's what you're feeling, the resistance back, divided by the effort force that you put in. So the effort is what you're exerting on the machine, and the resistance is what you feel. Or MA equals resistance force divided by effort force. FR stands for force resistant. FE stands for force effort. And remember, there is no unit for mechanical advantage. It is only a number. So there's no unit to add at the end of it whenever you do the calculation. It is just a number. That's all for machines, guys. Thanks for paying attention. Bye-bye.